Let's talk about a 19th century invention that was, well, less of a machine and more like a volcano in a box. It's the story of how we forged the modern world, quite literally in fire. And it reveals this dramatic, kind of dangerous conflict that sits right at the heart of pretty much all technological progress. I want you to just take a second and imagine a world without cheap, abundant steel, okay? So, no towering skyscrapers carving out our skylines, no vast railway networks stretching across continents, no massive suspension bridges. The entire skeleton of our modern civilization. It just wouldn't be there. And that, more or less, was the world before the 1850s. All right, so let's really set the stage here. Let's dig into the specific problem that one absolutely incredible invention was about to solve. See, before the Bessemer converter, steel was basically a craft good. It was made in these tiny, super labor-intensive batches that could take days to produce just a little bit. It was a luxury. But this whole process was about to get flipped on its head. We're talking mass-scale, mechanized and measured in minutes. It turned a luxury good into the foundational material of the modern age. And this is where Henry Bessemer's invention crashes onto the scene. It wasn't just an improvement, it was a heroic solution that completely shattered all the old limitations. This thing was a game changer, and honestly, that's putting it mildly. You know, the core idea was so brilliantly simple, and that's what made it so revolutionary. The process didn't need any external fuel. Nope. Instead, it used the impurities that were already in the iron. Things like carbon and silicon that make iron brittle, it used them as their own fuel. You just blast them with air, and they would literally burn away in this violent, self-sustaining chemical reaction, transforming weak iron into strong steel. Just amazing. The process itself? Deceptively simple and, frankly, brutally effective. You'd pour tons of molten pig iron into this giant pear-shaped vessel, and then you'd blast compressed air through it. And that would trigger this spectacular eruption of flames and sparks, and just moments later, bam! That iron was now steel. 20 minutes. That's all it took. A process that once took skilled craftsmen days to finish could now be done on a massive scale in about the time it takes to drink your morning coffee. This didn't just speed things up, it totally redefined the timescale of industrial production itself. And the result of that was, of course, immediate and dramatic. With steel suddenly cheap and everywhere, the material handcuffs that had held back civilization were just broken. The infrastructure of our modern world, the railways, the bridges, the very first skyscrapers could finally be built. But, and this is a big but, this incredible progress came at a staggering price. Okay, and this is where our story takes a really dark turn. The converter was a miracle of production, sure, but it was also an engine of unprecedented danger. It concentrated risk in ways that, frankly, nobody was prepared to handle. And the heart of the problem was this. The immense economic advantages of cheap steel were paid for, quite literally, with the health and lives of the workers who had to try and tame these industrial beasts. The conditions inside these steel mills were, well, they were hellish. I mean, we're talking about temperatures hotter than lava, violent explosions of molten metal. And get this, there were no reliable instruments. The operators had to judge the state of the steel just by looking at the color of the flame. A tiny misjudgment could lead to a catastrophic failure. And this systemic risk wasn't seen as a flaw to be fixed. It was just the accepted cost of doing business. But beyond all those immediate physical dangers, there was a more insidious problem lurking inside the metal itself, a chemical flaw that made the steel dangerously unreliable. So here was the crucial flaw. A lot of common iron ores had phosphorus in them, and the original Bessemer process just couldn't get it out. This left you with brittle steel that could just snap without warning. This wasn't just some minor defect. This was a hidden danger that was now being embedded directly into the new railways and bridges being built all across the world. And this brings us to the central paradox of our entire story. It was precisely these catastrophic failures, both the human ones and the chemical ones, that forced society to invent the systems that keep us safe today. You see, to survive the consequences of its own invention, society had to come up with entirely new ways of thinking. The converter's biggest failures actually became the catalyst for some of our most profound and lasting changes. So, to fight that chemical unpredictability, metallurgy had to grow up. It had to evolve from a craft based on intuition into a predictive science. You know, things we totally take for granted now: chemical testing, fracture analysis, quality control. These things didn't emerge from some academic lab. They were created as literal survival tools. Now, ironically, the instability of that early steel created a culture of extreme caution in engineering. Because the engineers couldn't fully trust the material they were working with, they started building things to be way stronger than they probably needed to be, using safety factors and redundancy. This practice of over-design is what made future structures so much more robust and reliable. And finally, that immense human cost. It just couldn't be ignored forever. The horrors of the steelworks became this powerful rallying cry for labor movements and reform. And that pressure led directly to the creation of the safety systems we rely on today, things like factory inspections, engineering codes, and government oversight. So while the Bessemer converter itself is now basically a museum piece, the industrial logic it established and the incredibly hard-won lessons it taught us, well, they're still with us every single day. You can see the lineage so clearly. The original Bessemer process was fast, but it was dangerously uncontrolled. So later technologies, like the open hearth furnace, they slowed things down to get that control back. And then modern furnaces, they finally achieved the dream. They are both incredibly fast and precisely controlled. They enclosed that original chemical violence within layers and layers of sensors and safeguards. You know, in the end, the converter story is much more than just history. It's an archetype. It's a timeless pattern. It teaches us that any powerful, world-changing technology is going to force us to build new kinds of knowledge, new rules, and new ethical frameworks just to manage the risks it unleashes. And that leaves us with one last thought. We see this exact same pattern again and again with disruptive tech, from nuclear power all the way to artificial intelligence. They offer revolutionary progress, but they also concentrate risk in new and unpredictable ways. So the real question you got to ask is, what is the Bessemer paradox of our time? And are we learning its lessons any faster than they did 150 years ago?